Good day, creators. Let me welcome to our technical mathematics lesson for today. As you can see on the screen that I will be taking you through the trigonometry. By the way, my name is Mr. Posa from African Trig. Before I can take you through this topic, I just want to tell you that remember trigonometry, it forms part of paper 2 and it's one of the topics that contribute a lot of marks. So whenever you are dealing with trigonometry, make sure that you practice everything and then you master everything that we have touched under trigonometry. Then let's see what we have. All right, under content, we have a subtopic under trigonometry. We have 3 subtopics under trigonometry. As you can see that this topic of trigonometry, it contributes 50 plus or minus 3 marks for paper 2. So it's very important that one should understand everything under this topic so that when you deal with paper 2, you know that you are going to make it. Now, the first subtopic under trigonometry is trig ratios, identities, and equations. Thereafter, we go to trig functions, and the last is 2D and 3D problems. Now, you should remember that in grade 12, we were only dealing with 2D problems because all these subtopic, we did them in grade 11. So it's going to be just a revision to us so that by the time we go and write our trial examination, we are well prepared and for the final examination. But for today's lesson is going to be mainly focused on trig functions. So I'm going to take you through trig functions and will explain the important part of that topic or subtopic. Now let me take you through that. The introduction. Now, what are we going to look under this trig function? We are going to learn on how to plot the trig functions or to draw the trig function. Then we have to be able to interpret the trig function as well, right? So these are the aspects that we are going to be focusing on today. All right. We are having the standard equation for different type of graphs that we have. As you can see on the screen, we have y equals to a sine k theta plus q. So one should remember, or we are going to remind ourselves about these parameters. How does a affect the graph of sine? How does k affect the graph of this sine as well as q? Then we are going to remind ourselves the effect of those parameters. Now, you should remember that the value of a in this case determines the shape and the amplitude of the graph. Meaning I'm referring to this. Let me just highlight it. I'm referring to this and this one. How does it affect the graph? It determines the shape and the amplitude of the graph. And you remember what is the amplitude? Do you remember what is the amplitude? The amplitude is the height from the center line of the graph to the maximum or the minimum. So, but we are going to deal with amplitude at a later stage. so that you can be able to understand what is the amplitude. Now we are having what? Q. It says the value of Q shift the graph vertically up or down. So if, for instance, you are having positive 2, it means that particular graph is going to be shifting by 2 units upwards. When it says negative 2, it's going to be shifting downwards with 2 units, right? That is the effect of Q in our graphs. Now, the last one, which is this variable K, and then how does it affect our graphs? It says value of K affects the graph, affects the period of the graph. The value of K affects the period of the graph. Now, one should remember on how does this K affect our graph. So I'm going to take you through that so that you can understand how does it affect the graph. If you still remember when you were in grade 10, dealing with the sine graph, the cosine graph, the original graph of sine, it has the period of 360. The original graph for cos, it say the period is 360. And the last one you can see we are having tan theta here. But for tan theta, the period for tan theta is equals to 180, right? But we have to understand how does this K affects our period. Now, it says we can find the period of a trig graph by dividing the original period by K. What is the original period? I just explained to you that the original graph for sine, the period is 360, right? So that is the original period. And then we go to cos. The original period for cos is also what? 360, right? Now, we are going to divide the original graph, or the original period by K, so that you can be able to determine what? The period. For instance, let's say we have y equals to sine 2 theta. And the question says determine the period of this particular graph, right? Now we can see in this case, the value of K is what? Is equals to 2. Now, how do we determine the period? You say period equals to original divided by 2, then it will give you what? The period of this particular graph, right? Now, the original graph for sine, it's y equals to sine theta, where K is equals to 1, right? Hence, the period of that particular graph is 360. But now, if now K is no longer 1, in this case is 2, then how do we determine the period? Here this period is equals to 360 divided by 2, which is equals to 180. That is the period. That's how we should determine the period. Now let's proceed. Now we are having another parameter, which is P. We also have to understand how does this P affect our graph for sine and for cos. So only P, it does only apply, or it only applies on sine graph and the cosine graph, not tan, right? Now let us see how does this P affect our graph. They say the value of P shift the graph horizontal, left or right. Meaning whenever you come across a situation like this, you will know that the graph has shifted horizontal. All right. That is that. Then let us proceed. All right. Now, we are going, like we said, that we are going to take you through of sketching the graph of sine, cos, and tan. So I'm going to show you on how easy it is to plot the graph of this one, which is the sine graph. Now we can see on the screen there, this is the original graph. Let me just remove this. All right, and then let me go back and take my pen. All right, now this is the mother graph for sine. This is the original graph, right? Now it says y equals to sine x. Y equals to sine x. Now, how do we plot this graph? Now it's very simple. You can use what? The table method. As you can see on the screen, they have used what? The table method, right? Now you have to plot all the points whereby you are having the x values there and then the y values. Then you're going to join all those values, all right? Then it's going to give you this curve. And this curve, we call it the sine graph, right? For instance, you'll be given what? The x values. You'll be given the x values. Yours is to do what? Is to take your calculator, and then, for instance, in this one, we have 0 degrees there. So you're going to say sine 0, which is equals to 0, right? So that is the y corresponding value. Then in this case, we have what? 30 degrees. So you're going to take your calculator and press that. And then we're going to say sine 30. So sine 30, the value of y is what? Is 0, 0.5. Right? Then you can see here, you are having 30 there. Then if you take it up, and then here's what? Positive 0, 0.5. Then you're having a point there, right? The first one, it was 0 is to 0 here. You can see that's point, and point number 2. And then you do the same with what? With this 60 here. You do the same with this 60. You take it up there, and then the y corresponding value there is 0, 0.87. It's somewhere here, just underneath this one, we have that 0, 0.87. Then it will give you what? A point there, right? And then we have 90. 90 equals to y. So x value, y corresponding value, it will be 1. So this is the point. And then the same applies with what? 120. You're going to have a point. You plot all those points. Thereafter, you are going to join all those points with a nice curve. Then it's going to give you what? The sine graph like this. So it's very simple to plot the graph, right? All right. Now, let me just remove this. Let me just remove this. All right. Now, since we have learned on how to plot the graph for sine, then we will be going to looking into these properties. The first property here, we have what? The domain. Then we have to learn the domain on how do we determine the domain for the original graph for sine, right? Now remember, when you talk about the domain, we are referring to what? To the x values, right? We are referring to the x values. So every time when you are being asked to determine the domain, you only focus on what? On the x-axis, right? Then you check where does the graph start. Now in this case, our graph starts at this point. Where does the graph end? Our graph ends at this point. Hence our domain is 0 degrees is to what? Is to 360. because at 0, that's where our graph starts, and then at 360 degrees, that's where our graph ends, right? That's how you should determine what the domain. Remember, the domain, we are referring to x values, right? Now, number 2, we are looking at what? The range now, the range. So when you talk about the range, there we are talking about what? The y values. The y values. Now, in this case, we can see that our graph range from where? -1 to positive what? 1, right? Now, you can see this, the graph, this is the turning point of the graph. The graph does not pass this 1, or is not above this 1, right? That is the range from -1 to positive 1. The same applies with this -1. You can see the turning point, it is exactly at what? At this -1, right? So the graph does not go below this -1. So that is the range. That means that our range is -1 to positive 1. That is the answer for the range. All right. Then we move to the x-intercept. X-intercept. Then our x-intercept is where the graph cuts the x-axis. In this case, you can see the graph x-intercept. It cuts x at 0 degrees. Hence, we are having that answer at 0 degrees there. Another point is this one of 180 here. You can see in 180. That is our x-intercept, right? And here's the 180 that we have. And the last point is this one. The last x-intercept is 360 there. But here there was a typing error. Actually, this is not correct. This 270, because 270 is not x-intercept. You can see our 270, it gives us what? It gives us -1 there. Here's the point of 270 is to -1, right? It's not x-intercept, it's just a typing error there. The correct answer is 360. So we are having 3 x-intercept, which is 0 degrees, 180, and 360, right? Then let's proceed. Then we now having what? We have to determine the y-intercept. Now, when you talk about the y-intercept, it's where the graph passes or touches or cuts the y-axis. Now, in this case, you can see our graph cut it here at 0 there. So our y-intercept is 0. Let me just erase this so that you can be able to see. All right. This 0 is what? Is our y-intercept, right? Then we are having what? The maximum value. The maximum value. So when you talk about the maximum value, we're actually referring to what? To the turning point of the graph, the y value of the turning point, right? In this case, this point here, this value, which is +1 here, is going to be what? Our maximum value. You can see is the turning point of this sine graph. So in this turning point, we just look what is our y value there is 1. So our maximum value equals to 1. Now, we then move to what? To the minimum value. Our minimum value is equals to -1. Now, the minimum value is here. It is this -1. You can see there is a turning point there. There is a turning point there. So you only focus on the y. Sorry. You only focus on y value of this turning point. And in this case is what? Is -1. So our maximum value is -1. Now, Now we're having what? The period. Now the period of this graph. Now let us study the period on how do we determine the period. Now when you start this graph here, it goes like this, it goes, and when it reaches this point 180, it's half wave, right? Half wave. Then if it continues until it reaches 360, it's a full wave. Then that's where it's going to give us what? Our period, right? I hope I do make sense. All right, let me just erase this. All right, that is our period, right? This graph of sine, it gives us the full wave at 360. And that, if that is the case, our period, it will be what? 360. Now, the amplitude, we are having the amplitude here. You remember we spoke about amplitude earlier on. Now remember what I said about the amplitude. On how do we determine the amplitude? I said amplitude is what? Is the height from the center line. Is here. This is the center. This is the center line to what? To minimum or maximum point. Meaning from center to this maximum, it will give us what? Amplitude. Now in this case, we can see that from here up to there, our amplitude is equals to what? 1. All right. All right. That is our amplitude. That's how you should determine our amplitude. So you just have to do what? To check where is your maximum or where is your minimum. So then you take from center there up to what? Up to the maximum. Then it will help you to determine the amplitude. So that is a sine graph. Then let's proceed and see what we have. Now, we are now going to be dealing with the cos graph or the cosine graph. Then we're also going to study on how do we sketch it, and we're also going to be focusing on what? On the properties of this cosine graph. Now, the same applies on this graph. When you have to plot it, you will be given the x values all the time, which we call them the independent values, right? You don't have to calculate the x values, right? But your work is to do what? Is to take your calculator and get the y values, the y corresponding values. For instance, when you are having x as 0 degrees, then you just take your calculator, you say cos 0 degrees, then the answer is going to be equals to 1. Then you're going to plot this graph. I mean that point. You're going to plot that point. Where is the point? Here's the point. We are plotting the point, right? Then you go to what? To 30. You do the same. You go to 60. You go to 90. You can see 90 is equals to 0. Here's 90. This is our 90 here. This is our 90 there. So 90, it produces y value as what? As 0 there. So we all know that in this line of x-axis, our y values is I think it's 0. Yes, it's 0. And then all right, now we are now at 180. You can see at 180, when the x value is 180, then when you take calculator, you press it, then you will have y corresponding value as -1. And then let me just take, all right, here's that point. That is the point. Then 270, 0. and then you just plot the point. You just plot the point. Then after you have done plotting the point, you just join all those points, and you will have this nice what? This nice curve. Just join all those points. Then it will give you what? The cosine graph. You'll have what? The cosine graph. So it's very simple to plot the graph of sine. It's very simple to plot the graph of what? Cosine. Now, let me take you to the properties of this graph of cosine. Now, the first we're going to be talking about is domain. Now, we're going to talk about domain. Now, earlier on, remember, I did explain when you talk about domain, we are referring to what? To the x values, right? We are referring to the x values. So when you come across this question where it says you should determine the domain, just focus on the x-axis. Then you check where does the graph start in that line, in this line of x-axis. Now our graph starts here. You can see 0, it starts here. X is 0 on this line of y-axis. So that's where our graph starts, and then that's where our graph is going to end. Our graph is going to end on this 360 here, right? Meaning our domain is 0 degrees is to 360, right? I hope you did. Let me just remove this. All right. Then let me have my pen again. All right. Now, remember, let me repeat. How do we determine the domain? You check where the graph starts. It starts here at 0 degrees and it ends here at 360 degrees. Then in this case, our domain is 0 is to 360. All right. Now let's proceed. And then we're going to talk about the range. Let's talk about the range. Our range, when you talk about the range, we are referring to y values. We are referring to y values. Now, in this case, you can see that our graph tends here at -1, at -1 here, and then also where? At +1. That is the range. So whenever you are being asked to determine the range, you're only focusing on what? On this y-axis, right? You are focusing on y-axis. Now the graph, it tends at -1 and also +1, meaning our range is from -1 to +1. That is our range. Now let's proceed. Now we have to determine the x-intercept. Now what is the x-intercept? It's where the graph cut the x-axis, right? In this point, we can see it cuts here at 90 and then also here at what? 270. So we are having two x-intercept, which is 90 degrees and 270 degrees. That is our x-intercept. Now we go to y-intercept. Y-intercept. When we talk about y-intercept, we are referring to a graph where it cuts what? The y-axis. In this case, we can see the curve of cosine, it cuts here at 1. Now our y-intercept is equals to 1. All right. Let me just clean my space here. Let me clean this. Also this one. All right. Now let's move on. Now we have to look into the maximum value. The maximum value. And earlier on, remember, when we were talking about the maximum value, we're referring to the turning point. The turning point, on that turning point, we are looking for the y value there. Now, look at the turning point here, because here the graph is going to turn here. Now, And the y value in this point is what? Is y. I mean, it's 1, right? So the maximum value in this case is equals to 1. Our maximum value is equals to 1 because this is going to be your turning point. So when you check what is the value of the turning point is 0 is to 1. But remember, when you talk about the maximum, we only focus on what? The y value of that particular turning point. All right. And then we moved to minimum value. The minimum value, we are talking about this turning point here. Now we can all see that the turning point, then we are having one, the y value as negative 1. So in this turning point, we don't consider the x value here. We only take what? The y value. In this case, this y value is going to help us to determine the minimum value, right? Then our minimum value is equals to negative 1. And then we go to the period. Let us look into the period. Now, then how do we determine the period? Then you are going to start at this point. Then this graph is going to go and go and go until to this turning point. Now, when you reach this turning point here, I think it's going to be half second, right? Or half wave. It's not yet the full wave. So in that case, you can't be able to determine the period if that is the case. Now, when the graph continues until you reach this point here, then it's going to give you full second, or it's going to give you what? A full wave. Then if it ends 360, then we're going to say our period in this case is 360, right? That's how we should determine the period for cosine graph. So whatever, let me just remove this. All right, thank you very much. Whenever you come across a shape like this, and then they refer this shape as cosine graph, you must know that it's going to be easy for you to obtain your period because it's a full wave. You just have to check what is the end point there. In this case, the end point is 360. So our period is now 360. Now the last point is the amplitude. Now I did explain the amplitude. Let me repeat what is the amplitude and how do we determine the amplitude. Remember, the amplitude is the height from the center line of the graph to the maximum or to the minimum. Now this is the center line here. The center, then when you take this center up to the maximum here, then it's going to give us what? The amplitude. So in this case, the amplitude is equals to 1. Our amplitude is equals to 1. So whenever you have to determine the amplitude, you just have to be able to know where is our maximum or where is our minimum, so that when you take a line from this center here up to the maximum, then it's going to tell you what is your amplitude, right? I think we have done with the cosine graph. We can now proceed. All right. Now we are going to be focusing on the tangent graph, which is the tan graph. Now on how to sketch this graph. Earlier on, remember, I also did explain that to plot a graph is a very simple thing, especially when we are using the table method, right? Then you'll be giving what? You'll be giving the x values. Yours is to take your calculator, then you just press what you see in this table. Now, for instance, if let's say we are having x there as 0 degrees, you just take your calculator, you say tan 0 degrees, then the answer is going to be 0 there. Then you have to plot that point. That point is here. You can see that is the point, right? Now we can take what? 45. If you take 45, then the y corresponding value there is going to be what? It's going to be 1. Then where is 45? This is the 45. So if you take a line up there, this is going to be the point. This is the point. This is going to be the point. Thereafter, what you're going to do, you're just going to draw a nice curve joining what? Joining those points there. So it's going to give you this terminal here. It's going to give you that terminal or this graph there. All right. Then now, I want us to talk about this 90 degrees. Look at here. When we have 90, when you say tan 90, it gives us what? It gives us math error. It's undefined. So if that is the case, it shows that at this point of 90, we are going to obtain what you call asymptote. So this line is going to act as asymptote. Now, what is asymptote? Remember, asymptote is that line, a line that graph will never touch it. You can see this graph is going to approach this line, but you never pass this line or touch this line, right? Because the graph is not defined in this point or in this line, right? The same applies with 270. There you can see 270. It gives us what? It gives us math error or undefined. So here at this 270, then we are going to have what? We're going to have the asymptote, right? Then the graph it will never touch this line. It will only approach the line, right? Now, then you'll have what? 135. 135, then the y corresponding value there is -1. Here is that point. You just join the point, and then you go to 180. 180 is what? Then 180 is the y corresponding value there is 0. And then it's at this point there, is at that point. And thereafter, you have what? 225. The y value is equals to what? 1. Then you also going to plot, you are going to plot that point. I think it is this point here. Thereafter, you're going to join all those points with a nice curve. You can see you just have to join all those points there. Then it's going to give you this curve. All right, let me just remove. All right, let me take my pen. Now, let us look into these properties for sine graph. Now, we are going to be talking about the domain. Let's talk about the domain of the tangent graph. How do we obtain the domain of the tangent graph? It said it's from what? 0 to 360 degrees. Now, remember what I said about the domain. The domain is you are referring to the x values. Every time when you're being asked the domain, you're only focusing on what? On the x-axis, right? Then you check where the graph starts. Remember the graph starts at 0 there, right? And it ends where? It ends at 360 there. Hence our domain is 0 is to 360, right? All right. Now let me just proceed. Then we are having what? The range. The range, when you talk about the range, we are referring to the y values, right? Then we're going to check where the graph starts. In this case, we can see that our graph continues. It has that. Let me just remove this so that you can be able to see what I'm talking about. Let me remove this. You can see this graph, it has what? Arrow there. Also, this one, it has that arrow there, and this one, it shows that this graph is still continue. Hence, our range is y is the element of all real numbers, or it can be written as y is the element of negative infinity to positive infinity, and the range for tangent graph, it will never change. It's always y is the element of all real numbers, right? Then let's proceed to period. Now let's talk about the period for tangent graph, right? In this case, they are saying the period is 180. Why 180? Now let us study this. Now when you look at this curve here, when you look at this curve there, this is going to be a half curve. You can see this is half curve, right? So it's not going to help us to get what? To get the period. Now let us look at this curve there, this one. You can see it's a half wave, right? So the same applies with this one. It's not going to help us to get the what? The period. But let us look at this one. We have, when it goes and reaches this point of 180, it's half wave. And if it continues and give us another nice curve, then it's going to give us what? The full wave. Then that's where it's going to give us what? The period of tangent graph. Now in this case, the period is 180. You can see at here at the 180, it's going to give us what? It's giving us the full wave at 180, right? I hope you do understand. So every time when you come across a tangent graph and it has this shape and this shape, right? Then you know that it's going to give you what? The period. All right. Now we go to the next one. It says no maximum value, no minimum value for this one. Because y does not have maximum value or the minimum value, because the graph is still continued. You can check it has what? The arrow there. The graph means it's still continued. It does not have the endpoints there. So we don't have, in this case, the maximum and the minimum, right? Then if that is the case, we don't have the maximum and the minimum. Surely we are not going to have the amplitude, because remember, for us to be able to determine the amplitude, we are focusing on what? Or we are depending on what? We are depending on maximum or the minimum value, right? Hence, we don't have that. Now, the last point we have is the what? Asymptote. We are having what? The asymptote. Now, in this case, remember I said the asymptote is this broken line that is moving vertically. And in this case, the asymptote, the first asymptote that we have is 90 degrees. And the second one is what? Is 270 degrees, right? We are having only two asymptotes in this case, right? I think that is that for the tangent graph. All right. Now let's proceed and see what we have. Now, we'll be focusing on what? Remember, we are done on in terms of plotting the graph of sine and cosine and the tangent graph. So now we are going to be focusing on what? Interpretation of the graph. We'll be focusing on the interpretation of the graph. Now let's see what we have here. Now the question says, given the graph f of x equals to sine theta plus q and g of x equals to a cos k theta for the domain where theta is the element of 0 degrees to 180. Now this is the graph. We are now given the graph. So we are going to be answering this question based on these two graphs that we're having, right? Now the first question says, write down the amplitude of g of x. Write down the amplitude of g of x. Let me remind you, earlier on, we talked about the amplitude. We said the amplitude is the height from the center line of the graph to the maximum, right? Now, which graph are they referring to? Write down the amplitude of g of x. Now let us go and look for that graph. All right. G of x is this graph. G of x is this graph there. Then we'll be determining the what? The amplitude of this graph. We can see this shape. Surely this shape is what? Is the cosine graph. So we'll be determining what? The amplitude now. Let us see what is the answer for the amplitude. Now our answer for this one is 2, right? Now how did these people obtain 2? Remember what he said, from the center, this is the center here, to what? To the minimum or to the maximum. Now we can see that our minimum in this case is -1. I mean -2. -2 is our minimum. So from center here, you take it to the minimum, then it's going to give us what? The amplitude, right? So our amplitude is equals to 2. Okay, let me just remove clean. All right. The next question says, what is the range? What is the range of f of x? Where is f of x? Is this one. F of x is this graph. We can all see the f of x. Now we have to determine the range. Let's see what is the answer for range. Now our answer for range is what? Is y is greater or equals to 1 and y is less than or equals to 2, right? Now let's go to this and determine that. Remember, when we talk about the range, we are referring to y values. Then in this case, the graph, you can see it starts here and it ends here. You can see there is a turning point there. There is a turning point there. So I think this turning point, the value of this turning point is 90:2. And then also this point here. So our range, our graph range between these two values, 1 and 2, right? 1 and 2. That's where the graph range. So that is the correct answer for the range. Yes, is the correct answer. Is the correct answer for the range. All right. Now let's proceed. Number 3, we have, what is the period of g of x? What is the period of g of x? Let us go and look for g of x. Now this g of x. Now remember, we said this graph, we can see this graph is what? Is the cosine graph. And we, by the time, earlier on when we were talking about the period, when we were dealing with the cosine graph, then I did try to explain on how do we determine that period. Now let us see the answer for this period. Now, the period for this particular graph is 180. Now, let us see how did these people obtain it. Now, from this point, when you have this curve until you reach this turning point, now it's a half circle or it's a half wave, right? Then if it continues until you reaches this point here, then it's going to give you this full circle of cosine graph. Now, in this point, you can see in that point is 180, right? Hence, our period is now 180. All right. Let me remove this. All right. Now, let's continue. Number 4, it says determine the values of A, K, and Q. Determine the values of A and Q. Now, let's proceed and see. Now, in this case, the value of A equals to 2. Where do we see A? Here's A. Now, remember earlier on we talked about this A. We said this A determines the shape or the amplitude of the graph, right? Now, they say it's 2. Then when you look at this graph, we can see this graph of g of x, we have already determined what the amplitude of that. And in this case, is equals to 2. Hence, the value of A is equals to 2. Because earlier on, we said that A determines the shape or the amplitude of the graph. Now, if you have the amplitude, then surely you're going to have what? The coefficient of this cos graph, which is 2. Now, let us go to K, and then K says equals to 2. Then let us see where do we see A? I mean, where do we see K? Here is the K, right? And then earlier on, we also spoke about K. We said K, it affects our period, right? K affects the period of the graph. Now, we can see this graph of g of x. We have obtained what? The period. We said the period of g of x is what? Is equals to 180, right? It's 180 in this case. Now, how do we get the value of k? We are going to say the original graph for cosine. The original graph of cosine divided by the original what? Period. Pardon? The original what? Period of what? Cosine graph divided by the period that we are having. In this case, the period is 180. So when you divide this original period with this period that we're having now, the answer is going to be 2, meaning the value of k there is equals to what? 2, right? And the last is q, the value of q. And then where is our q? All right, here is our q. Now, remember again, earlier on, we also touched on the effect of that q. We said q is it affects the graph what? Is vertically. The graph is going to move either upwards or downwards. Now, let us go to f of x graph. This is the graph. Now, when you look at this graph here, when you look at this graph, this is the sine graph. Now, the original sine graph normally starts at 0 here, but in this case, you can see that the graph is no longer starting at 0, meaning the graph shifted. So from 0 up to this point here, you can see the graph shifted 1 unit, right? 1 unit upward. Hence, the value of q is equals to 1, because the original graph, remember, start at 0 degrees. Now, in this case, It's no longer starting at 0 now. It starts where? At 1. Meaning the graph shifted 1 unit upwards, right? Then hence our value of Q is equals to 1.
Sure, my guy. Can you hear me?
Yeah, I can hear you.
Hello? Yes, check. I'm looking at the time now. Okay.
All right.
Can we try and wrap it up? Because now I'm looking at the time and we are going beyond an hour now.
Yeah, no, actually this is the last part, ne?
Okay, how long is it gonna take?
No, I think it's 2 minutes, so that I'm done.
Okay, please. So I just paused. It's fine. No, it's not gonna appear in our recording. So I'm gonna start recording in. Then you can. I think you can resume, but then please make it two minutes, please. Ne?
All right.
Okay, you can start in. You can just start where you left off now in 5, 4, 3, 2, 1, and continue.
All right. Now we just determine the value of Q. Now the last question, write down the coordinate of 1 point for which f of x is equals to g of x. Then when you are dealing with question there, let us see. Now the answer for this is 90 degrees is to 2, right? Where f of x is equals to g of x. That point is the point of intersection, is where these two graphs meet. And that point is this one here. You can see on this point here, which is 90 is to 2, right? That's where the graph of f of x equals to the graph of what? G of x, right? Now you can have this activity just to strengthen your understanding or to recall what we have learned on this lesson, and practice so that you master all these concepts under this topic. My last words for you learners is that you should believe in yourself in all that you are, and then know that there is something strong inside you that is greater than any obstacle, right? Believe in yourself in everything you do. Thank you very much.